Okay, in this problem we have an Atwood machine we're looking at. So the goal is to just set up your basic Atwood machine, find some masses, find the acceleration and the tension. So let's go ahead and do that. An Atwood machine is just two different size masses hanging over a pulley. That's really all we mean by an Atwood machine. So I'm going to go ahead and make one of those. Real quick sketch, something like this. You'll have to excuse my pulley, it should be round, but oh well. So here's a string attaching one of these, here's a string attaching the other one. And I'm going to pick some masses, and I'm going to choose 2 kilograms and 1 kilogram just to keep it simple. Then we're going to put some forces in there because our goal is to figure out the acceleration and the tension. So I know that I have an mg down over here of 2 kilograms times g, and an mg down over here of 1 kilogram times g. I recognize there's tension in the string going the opposite direction. As you can imagine, this thing is going to accelerate this away. That tells me I'm going to make that way positive to make it easiest, and I know the tension is going to be the same on both sides, but it's got to be less than the net force down here, and it's got to be more than the force up over here. So for my tension force, I'm going to choose to draw it so it's, again, bigger than the force down on the right. Same size over here, but also smaller than the force down on the left. Something like that. Here's a T, here's a T, here's an M1G, here's an M2G. Alright, next job, we're supposed to find the acceleration and the tension. So we want to write two net force equations. So force diagram is made. That's first. Next job, write net force equations. Alright, so on the left side for the 2 kilogram, I have F net equals M2G minus T. And on the right side for the 1 kilogram, it looks like F net is T minus M1G. T minus M1G. Alright, next thing I want to do is write F equals MA. That is, write those again, but replace F net with MA. So F net for number 2 is now going to be M2 times acceleration. I just replaced F with MA. And again, I have M2G minus T. Same deal on the other side. This is going to become M1 times A. And over here I still have T minus M1G. Alright, so now we have two equations and two unknowns. Now we can use those two things to figure out the two things we're after, acceleration and tension. To make this fairly easy, I'm going to rearrange this equation and solve it for T, because I look like I'm going to leave T there. I'm going to leave this other one, M1A, and then I'm going to add M1G. And then I'm going to substitute that in up here. Let's see, so that'll take this equation with a new one subbed in to be M2A equals M2G, and then minus, I'm going to distribute M1A, and then also minus M1G. Looks a little messy. I'm going to put the A stuff on one side, the G stuff on the other side. So I've got M1 plus M2 times A shows up on one side, and on the other side the G things are left, and it looks like I have M2 minus M1 times G, something like that. And then our last step in this case is to solve for A. So what's A? Well, it looks like the difference in the masses divided by the sum of the masses times G. That's kind of neat. So if the masses were the same, it would accelerate 0. If one of the masses were 0, it would accelerate at G. Huh, kind of neat. And again, now if you wanted to find the tension, we could take and stick this expression for A back in, up into either one of these, and that's probably your quickest approach. Because we would have, for particular numbers, in this case, let's just put in the numbers. 2 minus 1 is 1, and 2 plus 1 is 3, so we'd have 1/3 of g would be our acceleration for this particular case. And then if we knew that, then we could put it in here, and we'd have, m1 times g over 3 plus m1 times g, and that would get us our tension, yeah? So let's see, mg and mg and a third, so that's 4/3 m1g. Sorry, that's a 3. So if we really wanted to get a number for the tension, there it is. Okay, that is a rundown on a generic Atwood machine.